GraphQL landscape. So I'm going to be giving a little bit of a high-level overview of what's happening in the space, a little bit of tooling, a little bit of approaches, and a little bit focus on performance because that's why GraphQL has some limitations, right? So we look at that. Rahul already stole my slides with the polls. I'm supposed to do the polls to understand the users here. So I see that we have a few familiar with GraphQL folks here. So, but I'll still go ahead and do like a GraphQL 101, right? For those of you who are new to GraphQL, it's a query language, right? It's an opinionated query language to just talk to your data, right? And as a consumer, as a client, you technically ask for what you want and you get what you want, right? That's the sell of GraphQL, at least from a client consumption point of view. Bring your own data. GraphQL is data agnostic. Write your own code if you want. Works across all languages and frameworks. The benefits of GraphQL is that because it has a schema and a type system, you have like a self-documenting API layer. So you define a schema, you have some types for a schema, and you can start exploring what the API layer looks like. So documentation is free. Think of it as like a better version of Swagger spec if you have worked with REST APIs. And you have like a UI, like a console UI, GraphQL, which lets you just autocomplete queries and start exploring the API, right? So you don't need to now look at or communicate with your backend teams to understand what's happening on the API. Most implementations are just simple HTTP plus JSON, right? It's nothing. There's no magic happening. GraphQL is just a special query language syntax that you can see over here. But otherwise, it's behind the scenes. It's just a HTTP call, a POST request in most cases, sent to one endpoint. So that's an important piece of information about GraphQL. It's just one endpoint, right? Whereas with REST APIs, you create a lot of endpoints for each use case that you have. So all of your REST endpoints, let's say you have like 40 to 50 endpoints, those become GraphQL queries or mutations, depending on whether you're querying data or you're inserting or manipulating data, right? So fundamentally, you have three concepts, which is queries, mutations, and subscriptions. Queries to obviously get data, read data from any data source. And you have something called mutations, where you're inserting or updating or deleting data, essentially. And you have something called subscriptions, which lets you access real-time data over WebSockets. And because you have the schema and type system, the way to query or do mutations and get a predictable response is much better with GraphQL, right? And if you look at this example, the GIF, you can see that you can ask for different number of fields, and you get a response which matches the format and the style of your query, right? So in this example, you get a user with ID 1, and you have a few fields. And you can also notice that address is also like a nested field within user. So you can ask for related fields in the same query, whereas a typical REST endpoint would have been fetch users and then fetch address after fetching the users, right? So you might have made two API calls. You can also like write a single endpoint which does that, but GraphQL lets you naturally do that querying multiple related fields in one shot. Cool. So let me look at the evolution of GraphQL as we go along and talk about more tooling and go on to talk about performance. The benefits of GraphQL started with it being like a great solution for front-end folks or the clients because of all the benefits that we just spoke about, right? Self-documenting API, you can ask for what you want, you don't need to communicate with different teams. The API is already there. If a field needs to be added, the backend teams implement it, and then give back the field, your front-end clients can just start integrating, right? That was the initial surge of GraphQL usage. And as data requests emerged a lot, right? The usage of GraphQL as a thin wrapper over REST APIs started to change. Now you see that you have GraphQL directly contacting your data source and also like proxying to your REST APIs, your gRPC, or just being like the single layer on top of everything, right? So previously, we used to have GraphQL as a wrapper to REST APIs, which in turn was talking to your database. But now you see GraphQL as a standalone layer talking to your data sources directly. So you have like greenfield apps building from scratch using GraphQL to talk to database directly. But as this started to become more popular, and this approach became more of a backend concern now. So front-end folks have already gotten the benefits, but now it has become a backend engineering concern where performance issues have started to come up once this happened. Now, there's a lot of ways to create a GraphQL server, and in GraphQL terms, we call this subgraph. And we'll look at in later slides why we call it a subgraph and what it leads to eventually. The most popular approach till a few years ago was schema first. This is the first approach introduced by GraphQL Foundation. You have a schema, you define types, you write some code, which is called resolvers, which resolves to your data. And your app basically just queries for your data and then gets it right. So this is your schema first approach. You define a schema, write resolvers, get data. Then you also look at different solutions where why do I need to duplicate schema when I already know what I'm going to write on the functions, right? For example, if you're writing a REST API, you start off with writing your actual endpoint function. So that came in code-first solutions where you define a GraphQL schema later, and it's automatically inferred from your resolver code. So the way you do it is the reverse, where you write the resolver code naturally. So you write the function logic for your API. And for example, if you're writing it in TypeScript, your schema gets automatically generated, or if you're using any type-safe tool, schema is just inferred from it, right? So you just focus on writing your resolvers, and schema gets taken care of. And then you also have domain-first tooling, right? Where both schema and resolvers can be inferred from your domain. And you just focus on writing your business logic and not worry about simple CRUD operations that you would typically write, right? So it's a slightly more automated way to say, do not worry about schema, do not worry about writing resolvers from scratch for simpler operations, but basically try to infer from your existing domain models, and then just focus on new custom business logic which are outside of your domain. Now, the other approach previously was you had GraphQL talking to databases and REST APIs. So you have one app talking to one GraphQL layer. Then you had teams collaborating where you needed like multiple layers of graphs. So you had one subgraph worked by a team A, team B works on a different subgraph, and you need a way to combine all of that and merge into a supergraph. So you need a unified way to query across all of your data sources across your organization in a neat way. And GraphQL lets you do that because you have a schema and you just merge across your schemas pretty seamlessly and expose a unified endpoint, right? Then it started to become like, hey, I now can merge across all data sources. All of my subgraphs can be merged. So now, what if I actually expose it to different kinds of apps, right? Now, you have this unified endpoint. Now, your front-end apps can consume, your mobile apps can consume, different teams, public APIs, or even internal apps which needs access to specific parts of your supergraph, right? So it becomes like a platform use case where GraphQL becomes your go-to language, query language, or an endpoint to just read across multiple sources, right? So the good thing is that your supergraph acts as the middle layer, as a multi-protocol layer to just talk to your data, and different teams will start working on different subgraphs. This is the talk, the landscape, right? We have plenty of tooling here that's happening, pretty noisy a little bit. But you look at from the top, you have the app, you have the GraphQL client. There are a few GraphQL clients over here. Might have seen popular implementations here, Apollo client, Relay, Urkel, and different clients have different approaches for caching and some nuances over there. Then you have subgraph tooling, the three kinds of subgraph mechanisms that we just saw: schema first, domain driven, and code first, right? So we have tooling across there, and schema first predominantly on languages and frameworks. Code first, again, most of the servers which support schema first might have a code first approach as well. So you can see some overlap there. And there's like domain driven, where you have tools which can infer your database and generate APIs. And we're seeing a lot of traction from large organizations, right? Yeah. Oh, yeah. This is pretty hard to. Yeah, let me. The landscape. Let me reshare. Unable to share them for some reason. Get to see my screen. Oh. Okay, I'm having a slight hard time figuring this out. Let me GraphQL handbook. Let me open this up. Is this a little better? Yeah, cool. So we have a few GraphQL clients over here. Apollo client, Relay, Urkel, and as I mentioned, the implementations differ with just a little bit of nuance in caching, the way they do caching. Relay is a slightly different framework with a very opinionated way to do data fetching, pagination, which is more cursor-based, whereas Apollo client or Oracle do not really enforce that, right? And specifically looking at subgraph tooling, we have schema first, domain driven, and code first, right? There's overlap between schema first and code first. most languages which offer a schema-first way to create a GraphQL server also gives you like a code-first way as well. And the only difference is that you don't manually write your schema, but then you just write your resolvers, and then the schema gets generated. The domain-driven, again, as I mentioned, inferred from your models. There are a few tools like Hasura, PostGraphile for Postgres, GraphQL Mesh does it for a few databases, GraphBase again. And I'm not included in this, but then Microsoft recently announced their Fabric API, which does auto-generated GraphQL on top of Fabric Data Warehouse and Azure Cosmos as well. So they've also added a domain-driven GraphQL approach recently. And looking at developer collaboration, which is like your API portal, discovery of your APIs, your schema registry, where once you have your GraphQL schema ready, how do you do breaking changes? How do you do an audit trail of things that are changing? How do you explore the APIs that are available for your organization? Let's say you have multiple teams contributing to your API layer. Now, how do you actually discover? Where do you actually discover? This is where your API portal and developer collaboration tools come in. And we have a few solutions which offer this as well. I might be missing a few, but these are some of the common popular ones. And you can probably see some of them repeating in different spaces as well. And finally, we have the Supergraph tooling, which is a little bit of the gateway concerns around API management, do a little bit of caching, monitoring, observability, and API security. And this is very specific to GraphQL because caching differs with GraphQL. Everything is a single endpoint. So with REST APIs, you could typically cache your REST endpoint because APIs are, you can do a GET request across different endpoints. But caching becomes different with GraphQL because there's only one endpoint, so you can't do HTTP caching. You have to do it at the query level. So the gateway has to be smart enough to understand what the caching layer should look like. And the API security also is different with GraphQL because, again, you can't block your APIs based on endpoints. So you have to, again, look at query. So you have to introspect the query and do security. And you have Supergraph tooling, where you can merge across different APIs. Yeah, there's more pizzas. Yeah, so you have Supergraph tooling where you have these solutions, which lets you merge all of your APIs, bring them in one place, have one unified endpoint, do federation across these data sources, and also take care of your API management concerns in production, like your caching and monitoring. And that's primarily the landscape tooling. So we've covered all kinds of tools here. Now, let's go into subgraph tooling here. Schema first is schema and resolvers. And they're typically language specific because, and I say that because Node.js has probably better support because GraphQL GraphQL.js was implemented in Node.js, and then they have the first class support as a reference implementation. And other languages have their own kinds of libraries. You have Strawberry for Python. You have GraphQL Java for GraphQL in Java. You have Hot Chocolate in .NET. So you have a lot of tooling, but they all slightly differ in the implementations. Code first, again, resolvers only, schemas inferred or auto-generated from your code, the function code, the resolver code that you write. Again, it's language specific. Any type-safe language makes it easy to write code first. So you're thinking about Java, which has types, or like Node.js with TypeScript. And the ones which doesn't have a native way to do this, you will probably resort to a schema-first approach. And domain-driven, again, as I mentioned, schema inferred and resolvers are compiled. So you have the schema inferred from your database, domain models, and the resolvers. For example, you have tables in your database, your resolvers are basically compiled, generated, I would say, rather than you writing it yourself, because it's pretty straightforward SQL to write. And specific look at the schema first tooling and domain driven and code first, so that we just looked at. Now coming to the performance considerations, right? You want to do efficient data loading generally, but the way GraphQL resolvers are, the nature of GraphQL resolvers makes it easy to do a select star from your table when you're actually directly connected to your data source. So you want to be able to avoid this select star problem. And this compounds when you're actually fetching across multiple tables, you're joining data across multiple tables and whatnot, right? You might have heard about this with GraphQL. You have this n+1 query problem, which we'll go over. Largely addressed by data loader pattern and like batching queries. And the performance issues when you are using GraphQL as a wrapper over REST APIs. There are a few concerns around that. So we'll look at that as we move along. If you look at the GraphQL resolvers here, and on the left you have the GraphQL query, which is to fetch some patient data with the name and relationships with that. You have a very simple resolver function which resolves to like patients.find, which will typically have the business logic to fetch that from your database or your data source. And you will resolve for each field or each node on the left. So you will write a resolver for patients, and you'll write a resolver for the bed relationship for the patient. Now, you can probably see that this, again, compounds as you start embedding more nodes in your query, as you start getting more relationships in your query. And for each patient, you'll probably be making multiple calls to the related data, right? Which is this n+1 query problem where you have author, you have addresses, and you have articles, and articles have tags, right? You're already seeing 3 levels of nesting. And if you're arbitrarily nesting these related data in a query, you'll be ending up making 1 + n + n square, and it compounds as you start making this more relational, right? This can be fixed with a data loader approach, where instead of actually resolving one node at a time, you batch all of that query and do one execution for one node. So you fetch all the authors once, you fetch all the addresses for the author once, and you fetch all the articles once, and again the tags for the articles one, right? So you make essentially 4 queries instead of 1 + n + n square number of queries. So you largely address this problem by reducing the number of times you hit the database. So the round trips actually reduce significantly. But you're still not eliminating the problem. You're reducing the problem to the number of queries that you're making. What are the problems with wrapping GraphQL over existing REST, right? Again, inefficient data fetching, because you're relying on the quality of a REST API. The REST API is probably already written by somebody else. And if you're writing a thin wrapper over that REST API, you're only bound to that API constraint. And if things change, you need to communicate to the folks who have written the REST API, which you have no ownership on. So it's not really like a particularly great place to be in. And typically REST APIs will return, let's say, a JSON blob, and your GraphQL query might not have wanted that data. And the perk of GraphQL is that you get exactly what you want, right? So with the REST API, GraphQL as a wrapper over this REST API, you're fetching more than necessary, which defeats the purpose of using GraphQL itself, right? And again, if you want to evolve the API, if you want to add more fields to your GraphQL interface, you're again dependent on the underlying REST API to be able to give this feature. So what does Nick Schroff, who's one of the co-creators of GraphQL along with Lee Byron, GraphQL was originally introduced in Facebook, right? Back in 2012, they had this use case where they wanted to deliver data to mobile devices where data, your 3G data was pretty slow, and the amount of data that you send is pretty critical, right? So they wanted to actually reduce the amount of data transferred, the payloads to be transferred. But with Facebook and the amount of data that they're dealing with, and the amount of data sources that they're dealing with, you needed something like a very large async data fetching stack to be able to even handle performance, with obviously like tons of parallelism involved. So without this kind of a data fetching layer in the middle, it's very hard to build like an efficient GraphQL server, right? And you can see that from the n+1 problem that we talked about and the select star problem that we talked about. So again, TLDR, even from the co-creators of GraphQL, you need some sort of an async data fetching stack to be able to do efficient GraphQL. So how is the industry then solving for performance today? How are people actually like building efficient GraphQL servers, right? And there has been some recent developments where we've seen something called Graphast, which was launched last GraphQL Conf, where there is a query planner and an execution. So you don't resolve your GraphQL query as you start looking at your fields. You have a query planner step, and you separate the execution step separately. So technically, if you're, let's say I go back to the query, something like this, the way you will think about this query execution is you plan the query, you plan what needs to be executed on your database by looking at the field, traversing the fields, and creating a query plan, and do not execute them on your database till you have a query plan. And then there's an execution step where once you have a query plan, you've compiled the query technically, so you have a single SQL statement or your NoSQL query to be done against your database. So you have that one query to be done, and you should be able to do the execution phase independent of the query planning step, right? So that's an approach which we've seen, and this works with Node.js. For a Java developer, there is GraphQL JPA query library, which lets you do that dynamic fetching. So execute your queries by compiling them in one shot. So execute one SQL to your database rather than multiple payloads, multiple round trips. And again, Node.js with Postgres, we have PostGraphile, which is an open source implementation. Same creator as Graphast, Benji. So that works pretty well, pretty similar to the compiler way of doing things, where you're getting a GraphQL query, you're compiling it into a single Postgres SQL query. So irrespective of the depth of your query, it becomes a single SQL query with PostGraphile. And Microsoft Fabric just launched their GraphQL API, which does something similar for their data warehouse. And if you're working with like multiple databases, Hasura offers a solution for all of these databases in one shot, right? So the essential TLDR is compile queries, do not resolve them if you want like a performant API, because data loader is generic, doesn't exploit joins. As we saw in the previous example, we still had to make 4 calls to your database. And it increases, it compounds based on the number of joins you have. So convert the GraphQL query into single efficient database query. Now, sometimes your single SQL query or your NoSQL query may not be the most efficient. So the way to do is leverage database specific stuff, like we're using Postgres, use JSON aggregations, using Mongo, use aggregation pipelines, create a pipeline and just execute, right? Do query push down into database. Let the database handle the query compilation, right? So yeah, leverage aggregations and pipelines. So what would this look like from a query point of view? You have this patient's query with a few fields being Here the bed table is a different table, so you're joining across them probably. And this would become like a SQL statement in one shot. Whereas in your other example, in writing your resolvers, you would have made 2 round trips to your database, one to fetch patients and one to fetch your bed data for each patient. And even with data loaders, you're hitting twice, whereas with this compiler approach, you're hitting your DB just once. So now, why bother with all this performance optimization, right? Like, I'm still fine with my REST APIs or making multiple calls to my REST API with GraphQL, or just making n+1 queries. Why even bother with all of this, right? And you're heading towards building a super graph where it's just not you today in the team building this GraphQL layer. As your API layer grows, or as multiple teams start contributing, right? You need like a federated data access layer, a super graph, so to speak, which needs a unified endpoint given to consumers for data access. And that needs to be fast and high quality, right? So what do we mean by fast here? Is it just performance? It's also time to API, right? You need APIs to be quickly created and like given for consumption to clients. We also need to have a performant API, right? And what do we mean by quality here? Can I do filtering, sorting, pagination, all of the standard API queries that you would have probably done for your application with REST APIs, right? So can I do all of that features with this GraphQL API? And will the other team that is building the GraphQL API in the organization, will they also have a standard way to do this across the data sources that they are communicating, right? For example, you have one team working with Postgres, building filters, sorting, pagination logic with GraphQL. You have another team building in Mongo, and they should ideally also support the similar kinds of features, right? You want to do pagination across your data sources. You want to do sorting or filtering across all of your data sources, right? So this is what I mean by quality. Your subgraph quality is important. And of course, performance matters more once you start joining across Postgres and Mongo, right? So this is what we mean by federated data access. You have data in multiple sources. You have a use case where you want to join them so that your clients can start consuming it. And the typical use case that we see is you have transactional workload in Postgres, analytical workload in Mongo or ClickHouse or whatever, right? And you want the ability to join across these sources when your internal teams, your admins, your BI applications, or anybody who wants to like join across this data in one shot would want this. And they would also want to do filtering across these, pagination across these, and sorting across these, right? So performance, time to API, and a high quality subgraph is really important, right? And then again, we've seen federated data access use case growing as the teams expand. And this is why you need to care about performance and also the quality of your subgraph that you create. So you're composing data from heterogeneous sources. And so it doesn't need to be just a database. It can be also like a REST API that you're merging with. And the assumption is that the GraphQL wrapper that you write over REST API should also support all of the quality parameters like your filtering logic, your sorting logic, and whatnot. And you're kind of dependent on the underlying API to give that, right? So what is the journey to the supergraph looking like? You start with a single subgraph, one database connected, you have a few queries. Then you go on to multiple subgraphs where you have more GraphQL adoption in your team. 2 different teams are working on the project, and you have 2 subgraphs being created. And you want to do schema stitching, which is 3, where you have subgraph A and subgraph B independently available right now, but you want it in a single endpoint, so you combine them and then do schema stitching. So you do a union of the schemas. Then comes your composite schemas, or sort of a federation scenario where you want to like not just do a simple union, but also want to do filtering across these data sources, across these queries. You want to join across them, do all sorts of these quality parameters of your subgraph, right? Which is filtering, pagination, and all of those logic. What else is there apart from federation? Like, is it multi-protocol? Do you want to do federation and high quality filtering logic, pagination logic across different sources, not restricted to just GraphQL APIs, but also as a proxy to your REST endpoints, to your multiple data sources and whatnot, right? And if you look at the graph, as the number of teams increase and the number of subgraphs increase, your federated data access layer becomes more and more important, right? So we've looked at this supergraph, and the last bit is the supergraph of sorts, slightly above your federation, which is just restricted to your GraphQL portion of your app. So what are the key components of a supergraph looking like? You want it like a unified semantic layer, right? You want to combine entities across your domains, across all your teams, into like one unified layer that you all can look at. You want a composable API. You just don't want a dumb way to unify them. You also want to be able to compose them and like talk to each other. So you want data from Mongo and Postgres and BigQuery talking to each other because they're related naturally. And you want to be able to compose them neatly, right? And you want as teams to collaborate really well. So you want federated SDLC and like governance. And you wanted a query planning and a distributed execution layer. We talked about query planning and execution for a single subgraph, where you actually compile it into a single DB query. You also need to now do this for a supergraph layer, where now there are multiple sources involved. So you can't do like one single SQL to your Postgres, but you also need to do one query to Mongo. So now how does your supergraph gateway do query planning, distributed execution of your queries, and prevent the same problem of n+1 or your select star problem, right? So your supergraph needs to also have like a query planner and a way to approach data loader when you're dealing with multiple sources. Supergraph tooling, we've looked at it a little bit, but there's federated gateway involved with lots of bells and whistles. So you need to look at security, caching, monitoring, and observability, right? And specific focus on this part of the diagram where you can see that once you're a supergraph layer, you need to be able to do all of these parameters really well. You can't just do a union of schemas or just do federation, but you should also be able to do API management stuff to be able to do production-ready APIs, right? So where are we headed generally with all of this work with subgraph to your supergraph journey, right? The GraphQL Foundation is working on like a composite schemas specification, which is supposed to like standardize a way to do federation across your sources. We're seeing GraphQL on data use cases emerging, especially from big tech. Microsoft launched a couple of instant APIs on their databases. AWS has for their AppSync service, they generate APIs on your RDS database. So instant, you don't write resolvers for your database. So you have Fabric API, AppSync on RDS. And there are other tools like Hasura, PostgreSQL, which does it for other databases as well, right? So at the end of the day, I mean, it's all solving an organizational problem, right? GraphQL is technically like, with its federation capabilities, just technically solving your team problem. You have multiple teams collaborating. You want a unified way to look at what's happening across the APIs. So GraphQL is at a good place to solve this. And this is not possible with other specifications like, let's say, REST API, because there's no standard way to merge all of them. You could have like a messy interface where you have thousands of endpoints coming in one place, and no clear tooling to do all of this federation capabilities across multiple sources, right? So GraphQL is in that sweet spot to be able to do this. So we're seeing large enterprises take this route to use GraphQL to solve their federation use cases.